All right, today is the day, and you see we're sitting here in the car, but don't get too excited. This is not a video about fitting seats. We're not that far along. We're actually revisiting an old problem. If you remember, about 10 videos back, we spent some time reinforcing these front A-pillars, and we're back to that problem again. There was still some flex in there, so we built some carbon fiber struts to insert in here, and that's what this video is about. Let's go see what we did. So to get this formed correctly, I'm going to make a template out of a piece of foam core. Start off by just tracing the outside edge of that A-pillar and trim that out, and then go back and give it a trial fit. Now, there's a little bit of a channel back inside that A-pillar that it's got to fit down into, so do need to do this trial and fit. Of course, we want this to fit as snugly as possible. And once it's done, I need to mark it so that I can scan this thing. And of course, my scanner's only going to be able to fit about 8 inches. Now we're going to jump a little bit into here and come back to the scanning process because I need to show you how this thing gets scaled and put in the computer. But we're going to right now cut out some carbon graphite. And we're going to make 4 layers into a flat panel and then cut the pieces out of those 4 layers and then bond it and make actually 8 layers. But for now, cut our carbon 4 layers and we're going to take it over to the bench and start laminating it into a flat panel. Now, in the other video, when we did the wheel wells, this is the kind of the same process. Work out on a glass panel so I get a nice flat surface to work on, something that'll release from and come off very easily. Put down some resin and just do my laminations. And that's just a matter of taking the carbon fiber, laying it onto the glass and the resin that's on there, and adding resin and squeegeeing it out, trying to keep a minimum amount of resin as possible in there. Of course, we're always after weight savings. And when we're getting into the carbon fiber, we're using a little more expensive material. And so it's all about weight, but actually keeping the strength to its maximum. Now, of course, this would have been much more proficient to have used a unidirectional cloth because most of my strength needs to be in one direction. But I don't keep that on hand. I just use this twill fabrics, which is the pretty stuff that everybody likes. But it's going to create plenty of strength for what we need. And of course, in the strength we're talking about in this is in stiffness. We are trying to achieve as much stiffness as we can in this, and that's why we're jumping into carbon here and going to the extra expense of the carbon rather than just making another thick flat laminate out of the S-glass. Like I said, squeegee it out, get the thing nice and well impregnated, and then we're going to put a peel ply on it as well. Now, peel ply helps consolidate it. We're not going to vacuum bag this thing, but nice clean surface on the one side off the glass. We'll take the peel ply off, and this thing will be ready to send off. I'm going to have these parts actually Waterjet cut. So to do that, I have to create files for it. So I took my template and threw it in the scanner. Just have a little flatbed scanner that does 8.5 by 11. So I have to take it into Photoshop. I have to take it into Photoshop. And once it was assembled in Photoshop, bring it into AutoCAD. That's why the tongue twister there. And once it's in AutoCAD, I need to scale that drawing to make sure I have the same size. So I took a measurement off of the physical part, draw a line on the screen that matches where I took my measurement, and then see that that line needs to be adjusted a little bit, or I should say the drawing behind the line needs to be scaled to match the line. And once that line seems to be close, I'm going to take one more measurement and verify, make sure it's all perfect. Go tip to tip on the ends and get my measurement, 31, about what I needed right there. So once it's correct, I'm going to go in now and into AutoCAD and you actually put the lines in, create my vector artwork. And those vector lines can create a file that the CAD system at the Waterjet cutter will be able to follow and use to trace this path in the cutout. And there it is. There's my file ready to go off to the Waterjet. Here's a picture at the Waterjet. Cut parts ready to go. Nice and shiny. And once I got those home, we need to now take another step and bond each one together. I'm going to go for, of course, the driver's and the passenger side. A couple other parts here. Now you're going to wonder why I made 2 parts and bond them together rather than do a layup of 8 layers. A couple of different reasons. One being that this produces a little less scrap material, and as we're using this carbon fiber, we're going to save as much as we can. The other thing is when you start to get really thick layers in your layup, the edges of the layup seem to taper off and you start losing like 1.5 inches, maybe even up to 2 inches sometimes, just because the taper off is not usable, where you want to keep that laminated part nice and flat. So you only get the interior of your flat panel layup. Anyway, that is the reason for doing this in 2 parts. So now we just need to go back and put a little epoxy, bond the 2 parts together. That'll give us our 8-layer layup. And I'm just gonna clamp these things up with just some inexpensive jaw clamps and go throw them out in the sun. Nice warm day, so it should take 6-8 hours all, and these things should be ready to move on to the next step. And need to get that one edge that's going to go up against the existing A-pillar nice and flat. And the magic of editing, it is cured. Take the clamps off, and we're going to go over and start getting this ready to bond it in place. And the first thing we need to do is scuff it up. Sad as this is the thing that everybody loves, is the look of carbon fiber, and we're going to scuff it up. But we want to make sure that when we put our bonding fiberglass on there, it attaches extremely well. Also need to do a little prep on the tub itself. There are some ragged fiberglass edges I'm going to trim down, sand down, just so that once this reinforcing carbon pillar is in place, I'll have had that sanding done. Won't have to worry about it being in my way for that process. Once this is all sanded up, I need to also scuff in that channel of that A-pillar. I won't take you to the process of that, but took a piece of sandpaper and scuffed that up for the bond as well. So to put this part in, I mixed up a little bit of microspheres, thickened up some epoxy. That's going to be my glue to kind of hold it in place while we get some fiberglass to do the actual bonding. But that thickened epoxy will help the bond a little bit, but mostly just to keep this thing in place while we work with the fiberglass. Start off by throwing some resin on, and then we're going to put 2 layers of 2x2 twill fiberglass in there. Of course, they're using the twill again because it conforms so well to the drastic curves that we're taking. But again, this process is probably, those who've been watching these videos, getting to be pretty familiar. Saturate the fiberglass till it goes translucent. Once it's translucent, you know you're ready to move to the next piece or go to the next layer. And we're also going to do a little lamination on the back side of the little thin bulkhead you see that it's attaching to. Kind of a prepping for more build-ups as we get into this in the future. And this steps, we're just going to put 2 layers to hold this thing into place. We're not going for the maximum strength yet because we have lots of laminations that will just keep tying together into the bulkhead and this A-pillar. Ultimately, there's also another little flange that needs to be created out of a flat panel to make our kind of a rain gutter, our little trough for the weather seal to hook onto. But this will give enough layers to hold this thing in place and see what our strength factor is going to be. There it is, all laminated in place. And as I said, we also did a little bit of lamination to the backside to hold this bulkhead. Okay, so that is a huge improvement in the stiffness of that A-pillar. People using that to climb into the car now will not find so much flex in it. The only thing right now is with some load onto it, it is transferring that load into this panel that is not yet fabricated completely. There will be many more layers under that. We know that's going to occur, but I think that that load and that transfer is now made that A-pillar strong enough for what we need to achieve in this build. Anyway, thanks for stopping by and come back and see us again.